Hi, welcome to Thread Notification Wait and Notify module. I'm Buddha from pluralsight. During this course, I'm going to show how threads can coordinate with each other, explain the usage of notify and wait methods, and solve a simple ping-pong threads problem. Understanding this problem will help you solve complex producer-consumer problems. In a setup where there is a server producing data and clients consuming it, there are two approaches to trigger data transfer. One approach is called polling. Clients can poll for new data regularly. However, this is not efficient as server keeps responding and a lot of traffic is generated by repeated polling. A better approach is to use notifications where server notifies the client when there is new data for consumption. Before we learn how to apply notifications in threads, let us quickly revise what threads are. Computers can run multiple applications at a time. Each application is a process. If we look closely into a process, we see that multiple subprocesses are running in parallel. While the user is typing in a document, the word processor is simultaneously doing a spell check. Processes achieve this concurrency by means of threads. Threads are independent paths of execution inside code. You may be wondering how computers can run multiple threads simultaneously even when a typical computer has only one processor that can do only one calculation at a time. In reality, they run one at a time. However, they are switched quickly to create an illusion of concurrency. Here is a simple thread class. It extends thread class and overrides the run method. When this thread is started, it prints numbers from 0 to 99. To start a thread, we have to create an instance of the thread class we created and call the start method. Once the thread is started, the main method continues execution without waiting for the thread to finish its run method. The way they are designed, there is no way for us to control how much time each thread gets, so we cannot guarantee equal share of CPU time. Let us look at this in action. Here is the simple thread class that prints from 0 to 99. The run method is automatically called when the thread is started. In order to start the thread, I've created simple runner class. Runner class starts the thread and proceeds to print from 100 to 1 without waiting for thread to finish. So both print operations run simultaneously. Let us run and see the output for multiple times. It is clear that every time we run, the output will be different, which shows that we do not have control on how these threads are switched with current design. Now, let us understand the problem we want to solve in this module. Imagine two threads. Thread 1 prints out once repeatedly whenever it gets to run. Thread 2 does the same, except that it prints twos. Now, here is the problem to solve. We have to design these threads in such a way that whenever these threads are started concurrently, they should produce an output of alternate ones and twos. As we have seen in the previous demo, we can't control how these threads run. If we run them as is, the output can be like this, or it can even be like this. However, what we need is exactly 1 1 followed by 1 2. Let us find out how to solve this. One solution that comes to our mind is, if a thread sleeps for a brief period after every time it prints a number, other thread will get a chance to print and sleep. However, neither of the threads know how long to wait. Do we say 1 second or 10 milliseconds? It can be too long to keep the process idle or too short to wait until the other thread wakes up and prints. Both can lead to unpredictable outputs. Let us look at a better approach. Instead of sleeping for a predefined time, we can modify the approach so that each thread will notify the other thread before going to sleep and the notified thread wakes up to run. In Java, we use notify method to notify the other threads. As sleep method requires a time parameter, we use wait method. But there is still a problem. How does thread 1 know which thread to notify? There can be many threads running simultaneously on unrelated tasks. In order for a thread to wake another thread, we may be tempted to maintain the reference of other thread. However, this is not a good practice. Java solved it by implementing notification mechanism to work alongside of synchronization. Synchronization is a process of locking an object so that it is available only to one thread at a time. All the threads that work in coordination will set a single object for synchronization. Instead of a thread trying to wake another thread, it will simply notify the object, which in turn wakes up another thread waiting to acquire lock from waiting state. This is why notify and wait methods are actually implemented on object class. Putting everything together, it works like this. A thread acquires a lock by entering a synchronized block and prevents other threads from acquiring a lock on the same object. Meanwhile, the second thread starts running but can't enter the synchronized block. The first thread performs the necessary work and releases the lock temporarily without leaving the synchronized block and requests the object to notify other threads waiting on same object. Once notification is gone, the first thread waits. The same approach is followed by the second thread. The cycle repeats until both threads complete their work and leave the synchronized block. Let us look at it practically. Thread of 1's class is similar to the simple thread demonstrated in the previous example. This simply prints ones in a loop. Thread of 2's just prints twos in a loop. Runner class is written to start these two threads at about the same time. If we execute runner.java, it is evident that the output is random, not the expected one. Let us bring in the wait and notify methods into the picture. First thing we need to do is synchronize both threads on one object. Runner.lock is created for this purpose of synchronization. We use synchronized keyword to synchronize. Next thing to do is call notify method on lock object to tell other threads that the current thread is releasing the lock. Once notified, we need to call a wait method on the lock object to indicate that this thread will wait for acquiring lock on the same object until notified. We can either call wait method without parameters indicating that this thread will wait indefinitely, or can pass an optional timeout parameter. It's a good idea to use wait method with a timeout because this can prevent some deadlocking. If for some reason thread of 2's dies without notifying thread of 1's, wait method won't cause the thread of 1's to wait forever if we had used a timeout. The call to wait method must be enclosed in a try-catch block. The reason being, the process of waking from sleep or wait is done by interrupting a thread sleep, which produces an interrupted exception. Same has to be applied to thread of 2's as well. If we run the runner.java now, we should see the expected output, alternate 1's and 2's. However, many times we may run this program, we see the output consistently as expected. In this course, we have understood how to use wait and notify methods for thread notification. We have also seen how to solve a simple ping-pong threads problem, which lays foundation for understanding the approach to solve the complex producer-consumer problems. Thank you.